Hey guys, we're going to start Unit 5 today of our linear functions. The first section is section 5.1, rate of change and slope. Our learning goals are to find the rates of change from tables and to find the slope, which you've probably done before. First off, the rate of change shows the relationship between two changing quantities, okay, like miles per hour. When one quantity depends on the other, the following is true. The rate of change is equal to the change in the dependent variable over the change in the independent variable. Okay, first problem. The table below shows the distance a band marches over time. Is the rate of change in distance with the respective time constant? What does the rate of change represent? So from the previous slide, remember the rate of change is equal to the change in distance. Let me see, where's my pen? Hold on 1 second. Remember the rate of change is going to be equal to the change in distance over the change in time. Okay, so if you look at our table, what it tells us is that when time passes, as each minute increases, so when they march for 1 minute, they cover 260 feet. When they march for 2 minutes, they cover 520 feet, 3 minutes, 780, and so forth. So as you can see, what's the increase each time? What's the distance increase each time a minute passes? Okay, think about it. What's the increase they're doing each time from 260 to 520 and then to 780? Okay, so as time passes, they're covering an extra 260 feet, right? Every time, right? So 520 to 680 is another 260, right? Okay, so how can I calculate the rate of change from one row of the table to the next? Okay, so here, since our rate of change is the change in the distance over the change in the time, our change in the from 1 minute to 2 minutes, our change in our distance is 520 minus 260 over 2 minus 1. Does everybody see that? Okay, so 520 minus 260 over 2 minus 1. So it's the change in my distance over the change in my time. Okay, once I calculate that, what's 520 minus 260? 260. What's 2 minus 1? 1. So here, my rate of change is 260. So let's try it again from going from minutes 2 to 3. Okay, so at 3 minutes, my band has marched 780 feet minus, from 2 minutes, 520 feet, all over my change of time, which is 3 minus 2. Okay, so 780 minus 520 over 3 minus 2 is going to be equal to, what's 780 minus 520? 260 over 1. Okay, so since every time it increases so far, it's constant, let's make sure it stays the same between 3 and 4. So at 4 minutes, my band marches at 1040 feet minus 780 all over 4 minus 3. Okay, that's also going to be equal to 260 over 1. Okay, so since it stays constant, my band marches 260 feet per minute. So my rate of change is constant. My band marches 260 feet per 1 minute. Okay, does everybody understand rate of change? So rate of change talks about the change in the distance over the change in the time. Okay, looking at the previous slide, so it's change in the dependent variable, the change in the independent variable. Here, my distance depends on the time. Time is independent. All right, moving on. The next thing we're going to talk about is slope. The slope is also a rate of change. It's the rate of change of your line. So, looking at the definition, the slope of a non-vertical line is the ratio of the vertical change to the horizontal change between 2 points. Okay, you've seen this formula before. M is the vertical change or the horizontal change or the rise over the run. Okay, these are multiple ways of looking at the same thing. You've also probably seen the slope formula. If you're given 2 points, x and y, so x1 and y1, and another point, x2 and y2, you can calculate the slope by subtracting the change in your y variables over the change in your x variables. Okay, it's another way of finding the slope. And a third way of finding the slope is to actually, if you're given the graph, you can find the slope by counting the rise over the run. So if I'm wanting to find the slope between points -2, 1, and 0.43, I can count up from this point to the next one. So my change in my y is going to be, I'm going to go up 1, 2, 3, 4, right? It's positive 4. And my change in my x variable is going to be going over 1, 2, 3, 4, 5, 6. So if you look here, what I did is my rise was 4 and my run was 6. Okay? To reduce that, I get 2/3. So if you plug those 2 points into the slope formula here, you will also get 2/3. Okay. So plug it in here. Here, with the slope calculated using this formula here, you plug 3 in for your y2, and then minus -1 in for your y1, over 4 for your x2, minus -2, which is your x1 variable. You also get 4 over 6, which is 2/3. Same thing that you get when you count. You go up 4 over 6. Since the slope, we read this slope from left to right just like we read a book. So when you look at this line from left to right, it is going up, right? So since it is going up, that means our slope is positive. If we read from left to right and our line is going downward in this direction, that means our slope is negative. Okay, so always check and make sure that your answer is positive if your slope is in fact going up from left to right. All right, so I want you to find the slope using the graphs for number 2 and 3. Okay, so remember you find some point on your slope, on your line, and then you count going upward and then over. So let's do the first one together. Okay, find a point at where the line crosses at an exact point. So here. So my line crosses the exact point at -1, -2, right? So the next time that it crosses at an exact point is here at 1, 1. So let's use our counting method, rise or run, to see what our slope would be. I go up 1, 2, 3. So my rise is going to be a +3 since I'm going up. And my run, when I get up here, I go over 1, 2. So my slope is a +3/2. Rewrite our slope as M. Okay, do number 3 on your own. Find a point where it crosses find a point on the line where it crosses a point exactly. Find 2 of those points and then count the difference between the 2. I think this is the same problem. My apologies. If you look at it, it's the exact same problem. I meant to put a different one in there, but it goes up 3 over 2, so it's the same. Okay, finding slope using points. So find the slope of the line that passes through each point. So here we need to use our equation. Remember, your equation is m is equal to the change in your y's. Okay, so y2 minus y1 over the change in your x's. Okay, so for this problem, my y variable is going to be y2 is going to be -2. And my y1 is going to be 0 over my x variable, which is going to be 3 plus 1, because 3 minus a -1 is plus 1, right? So -2 minus 0 is going to be equal to -2, right? What's 3 plus 1? 4. So when I reduce that, I get my slope is equal to -1/2. Okay, excuse my messiness. It's my first time doing this, so it's -1/2. Okay, try to do number 5, 6, and 7 on your own. Redo the y's, difference in your y's, over the difference in your x's. Five minus 3 is 2. 5 minus 1 is 4. What does 2/4 reduce to? 1/2. Good. Okay, so your slope for number 5 is 1/2. On number 6, changing it. If you need a pause, you can at any time. So number 6, okay, the change in your y is going to be 2 minus 2. Change in your x is 2 plus 3. Plus, sorry about that. Okay, what's 2 minus 2? 0. What's 2 plus 3? 5. What's 0 divided by 5? It's 0. Good. So if my slope is 0, that means I'm going to have a horizontal line. Okay, remember horizontal goes from left to right. Okay, and then number 7. Same thing here. Use your equation, changing your y's over to changing your x's. So 1 minus -2 is 1 plus 2. And then -2 minus 2 minus -2 is -2 plus 2. All right. Remember, I keep my numerator and my denominator in parentheses because I put them in my calculator. My calculator does not know order of operations. I have to impose it. So remember, the first step of order of operations is PEMDAS, parentheses. So make sure you keep your numerators and denominators in parentheses. So what's 2 plus 1? 3. And what's -2 plus 2? 0. What's wrong with this fraction? Right, you cannot balance a fraction on a ball. Remember, we cannot divide by 0. If you divide by 0, it is undefined. Okay? So if our slope is undefined, okay, that means we have a vertical line. So a vertical line, remember, would not pass the vertical line test, right? So that means that we do not have a function. It's undefined when our slope is undefined. All right? Everybody understand that? So you cannot divide by 0. So when the change in your x's comes out to be 0, then your slope is undefined. Okay, so a concept summary, positive slope, we always read our lines going from left to right.